Have you ever gazed up at the night sky and wondered if the stars you're seeing are actually dead? Let's unravel this cosmic conundrum. Stars, much like celestial time travelers, communicate their tales across light years. This term, light years, encapsulates the distance light travels in 1 year. So, when we look at the stars, we're not seeing them in their current state, but as they were years ago. The star's light takes so long to reach us that some stars we see may no longer exist. Every star you see in the night sky began its life in a similar way. Stars, those dazzling celestial bodies that dot the night sky, have a rather humble origin. They're born from cosmic dust and gas clouds that float aimlessly in the vast expanse of the universe. Picture a nebula, a giant region filled with dust and gas, just hanging out in the cosmos. This nebula, in all its quietude, is a star nursery, a place where stars begin their life. The birth of a star is a complex process that unfolds over millions of years. In the heart of the nebula, particles of dust and gas start to gravitate towards each other due to the fundamental force of gravity. As these particles collide, they start to form a clump, a dense region within the nebula known as a protostar. The protostar continues to grow as more and more cosmic dust and gas are drawn into it. As the mass of the protostar increases, so does the force of gravity at its core. This causes the particles to move faster and faster, creating a tremendous amount of heat and pressure. Now, here's where things get really interesting. When the core of the protostar becomes hot and dense enough, a process known as nuclear fusion begins. The heat and pressure force hydrogen atoms to come together to form helium. This reaction releases an enormous amount of energy in the form of light and heat. That's when a star, as we know it, is born. The glow from this reaction is so bright and powerful that it pushes against the inward pull of gravity, creating a stable star that could shine for billions of years. The process of star birth is a testament to the power of the universe's fundamental forces. It's a cosmic dance of dust, gas, and gravity that creates the beautiful night sky we admire. It's a process that reminds us of the grandeur and mystery of the cosmos. From humble beginnings in cosmic dust, every star embarks on a fascinating journey. A star's lifespan is determined by its mass and the fuel it has to burn. Now, you might be wondering, what exactly is this fuel? The answer lies in a process called nuclear fusion. In the heart of a star, where temperatures are incredibly high, hydrogen atoms collide and fuse together to form helium. This process releases a tremendous amount of energy, which we see as light and feel as heat. It's this energy that powers a star and keeps it shining brightly in the sky. But not all stars are created equal. Some are small, and others are colossal. This disparity in size is not just a matter of appearance, it greatly influences a star's lifespan. Let's delve into this a bit more. Small stars, also known as red dwarfs, are the most common type in the universe. They have a lower mass, which means they burn their fuel more slowly. This slow and steady approach allows them to live for trillions of years, far longer than the current age of the universe. Red dwarfs are the tortoises of the stellar world, enduring and unchanging. On the other end of the spectrum, we have the giants or blue supergiants. These stars have a lot more mass and therefore burn their fuel at a much faster rate. Their lives are a blaze of glory, bright and spectacular but tragically short. A blue supergiant might only live for a few million years before it exhausts its fuel and meets its dramatic end. In between these extremes, we find stars like our Sun. Medium-sized stars have lifetimes that span billions of years. They live long enough for life to evolve on any planets they might have, making them particularly interesting to us humans. Whether they're small and enduring or massive and short-lived, every star has a unique tale to tell. So the next time you look up at the night sky, remember, each point of light is a star on its own incredible journey. Just as they are born, stars must also die. This might sound a bit dramatic, but it's a fundamental truth of our universe. The death of a star isn't an end, but rather another phase in its cosmic journey. Let's start with the smaller stars, those similar in size to our own sun. After burning through their nuclear fuel for billions of years, they start to cool down and expand into what we call a red giant. This phase is short-lived though. The outer layers of the star eventually drift away, leaving behind only the core. This dense, hot core is what we refer to as a white dwarf. Over many more billions of years, this white dwarf will cool and fade until it's no more than a dark, cold, stellar corpse. Now, when we turn our attention to the more massive stars, their deaths are much more dramatic. Once they've exhausted their fuel, These stars collapse under their own weight, triggering an explosion of astronomical proportions. A supernova. This event is so bright, it can outshine an entire galaxy for a brief moment. What's left after this celestial spectacle is either a neutron star or, if the star was massive enough, a black hole, the gravity well from which not even light can escape. In death, stars offer one final spectacular display before their light fades. So, in a sense, each star's demise is its own unique curtain call on the cosmic stage. When we gaze at the stars, we're actually looking into the past. It's a concept that might seem a little hard to wrap your head around, but it's rooted in the basic principles of astronomy. You see, light travels at a constant speed, about 186,000 miles per second. This speed is so vast that we use the term light year to describe the distance that light travels in a single year. So when we observe a star that's, say, 1,000 light years away, we're actually seeing the light that left that star 1,000 years ago. Which means, we're seeing the star as it was a millennium in the past. Now consider this. Stars, like everything else in the universe, have a lifespan. Some of those distant stars we see twinkling in the night sky might have already burned out and died, their light still journeying towards us. So, the next time you look up at the night sky, remember, you're not just seeing stars, you're witnessing cosmic history.